So we have seen in the last part from this example that these were the probabilities what we had with respect to x as 0, 1, 2, 3, 4. Now the same one, let me just change a little bit in this example, stating that maybe my values are now going to be for 1000 players. Let's say, though I have done it for 75 players, but let's assume that it is done for 1000 players. So in that case, total number of uh, players with red ball is going to be 160. So I'm talking about with one red ball. Okay, means because my probability that x is equal to 1 means I have only one red ball was 0.16. So if this experiment was conducted for 1000 people, in that case there will be 160 people who will be who will be drawing one red ball. Similarly, there will be 347 people because the probability that x is equal to 2 came out to be 0.347. So that means there will be 347 people roughly who will be kind of getting the two red balls. Similar thing, we gonna get it for all the remaining values as well. So we can see all these possibilities with us. So now what we can do is we can compute this. Basically what we want to now get is we want to compute total number of red balls in this case. So in order to get the total number of red balls, we can say that 0 multiplied by 27 because here I have 27 balls. Similarly 1 into 160, right? 2 into 347, the 1 is missing here. So there will be px3 is going to be 333 number. So here 3 into 333 because you are drawing 3 red balls. 4 into this because you are drawing 4 red balls. So multiply by 133 and you got 2385 values. This is the total number of red balls what you're gonna have. Now with this knowledge, if I ask you that what is if you are playing one game, so in one game what is the number of red balls you can get on average? So it's going to be 2385 divided by 1000 because you played 1000 games and you got total 2385 number of red balls. So it's going to be total as 2.385, right? Now let's define a term called as expected value. So this is from where we can define the expected value. So what is expected value? Expected value for a variable x is the value x we would expect to get after performing the experiment once. So like in this case, you can see that I have x is equal to x1 to xn, let's say. I'm just generically defined. In the last example, we could have said till x4. So I can define my expected value as x1 into, because this is basically what? This is your x1, x2, x3 from here. So this means that if I have to talk in terms of red balls, so means number of times one red ball came and so on. So x1 into p of probability that it have x1 value. Similarly x2 into this value, x3 into this value, and till xn. Like so, if I have to put the same value for my last experiment what we did, so we got 0 into 0.027, 1 into 0.160, and so on for all the probabilities I'm gonna keep, and I got my expected value as 2.385. Okay. Now this is the value which you gonna get, right? So because as I said, expected value for a variable x is the value x we would expect to get after performing the experiment. So in this case, you can see that I'm getting like if you're playing the game 1, you have more of the expected value that you can draw 2.385 balls, right? So the of red balls. So this is what we get after performing the experiment. So you can also call the expectation as average or mean value. Okay. So mathematically, I have just explained you that this is how you define this term, right? Now you can see that here the expected value came out to be 2.385. What does this mean, right? Uh, how does this is even going to help us in the original question what we had? Which was like how much money on average a player are expected to make, because we want to see that whether that 150 rupees which I'm giving is going to go in profit or am I going to in loss. So can I really make some inference out of it? So this is what we will learn now in the next video.